So continuing on with some conditional probability. The conditional probability rule looks like the probability of A given B is equal to the probability of A and B divided by the probability of B. Now it can also be said that the probability of B given A is equal to the probability of A and B, and this time divided by the condition, the probability of A. So you see these are exactly the same. Now I'm not really telling you anything new here because you know we actually looked at this before. Remember when we said the probability of A and B? That was when we had dependent events. Actually the probability of A times the probability of B given A, or that it was equal to the probability of B times the probability of A given B. Remember that for dependent events? So we had dependent events and the probability of two events occurring in succession, or joint probability. Well, this, if you solve for B given A, you see that you divide both sides by A, and look at that. That's exactly what you have. Or here, if you solve for the probability of A given B, you'll have the probability of A and B divided by the probability of B, the conditional rule here. So those are the probabilities that we have. Now I want to focus in on a two-way table, and I want to talk about the probabilities given a two-way table because it's so much easier than this rule would imply to find conditional probabilities based upon a two-way table. So let's first of all just go ahead and look at the two-way table's probabilities. So what is the probability that a randomly chosen person smokes and is divorced? And let's see, I had put never been married in here, so let's go ahead and do that and change all of the ones that are related to that as never been married instead of single. It's easier for abbreviations. So what's the probability that a randomly chosen person smokes and is divorced? So the probability the randomly chosen person smokes and is divorced, if we look at that probability, remember that was an easy one to find because smokes and divorce, that was 38, and there were 38 with both of those characteristics out of the total number, the 350. Now, of course, we can find the decimal for this, and we'll do that really quickly. 38 divided by 350, and that's going to give us 0.108571, and I'll round that to 0.109. So this is approximately 0.109, and that was part A. Now part B on this problem says, what's the probability that a randomly chosen smoker is divorced? Well, guys, this is a conditional probability. This is a conditional probability because it says that I'm choosing from smokers. It's a randomly chosen smoker, just not a randomly chosen person, but a randomly chosen smoker. So the condition is that I have a smoker here, and the randomly chosen smoker is divorced. That's the condition that they have. So divorced, given that we already know they're a smoker. So this one, from a probability standpoint, from the rule standpoint, to give this probability of B given A or A given B, I'd have to find the probability of being both of these, right? The probability of divorced and smoker, and then divide that by the probability that they're the condition, which is smoker. Well, when we do this, let me show you. I'm going to put this in blue, so if you have a hard time seeing it, that's why. So you'll have to focus on what I'm saying. So divorced and a smoker, that's the 38 out of 350, right? 38 out of 350. And then the probability of a smoker, well, remember the probability of a smoker is there's 103 smokers out of the 350. And with a little bit of math magic, you know, just some basic math here, this, I know, fractions, oh gosh, this is 38 out of 350 divided by, because that's what the fraction bar means, right? This is 103 divided by 350. And then we multiply by the reciprocal, right? So multiplying by the reciprocal means we flip over the second fraction. So now we have 38 over 350, and that's multiplied by 350 over 103. And what we end up finding here is that our probability of being divorced, given a smoker, is 100, oops, excuse me, not 103, is 38 out of 103. And that was a really long way to go about finding this probability, because look at it this way. Look, if I were only saying, okay, here are my smokers, right? And I have all of these smokers, and I have ones that have been married, divorced, and single, and I had a frequency table based upon these just characteristics. So it would be just a table of values, right? And what I'd have is I'd have 54 in this one, and I'd have 38 in this one, and I'd have 11 in this one, and that would give me a total of 103, wouldn't it? And if I ask this question of all these people, just of these people here, the smokers, right? That's the condition. That's what you're looking at here, this condition. All these people, how many of them have been divorced? You'd look at me and you'd say, well, that's really easy to find. The probability of divorced, if I'm only looking at the smokers, which is what conditional means, would be 38 out of 103, which is exactly what we got by looking at the conditional probability rule in this really long terms. So what I'm telling you is that when you have a two-way table and you want to find a conditional probability, what you say is, okay, where's the box of overlap? 38. And my condition, the 103, those are the only people I'm choosing from. So my conditional probability is the box of overlap divided by the number of people meeting the condition. And that's it. That's my probability. Now, of course, we'll have to change this to a decimal. So let's see, 38 and divided by 103. And that probability is 0.368932, so approximately 0.369. So approximately 0.369, and that's my conditional probability. Now the next one says, what is the probability that a randomly chosen divorcee smokes? Well, a randomly chosen divorcee, that's my condition. They're divorced people this time. And now I'm looking at the probability of them smoking. So this time I'm only choosing from those who are divorced, right? So that's my condition. That's my number of people I'm choosing from. And then I'm looking for the divorced smokers. So this is 38. Heck, I don't even need a calculator for that, right? That's just simply 0.380. And those are my probability of being a smoker, given that I'm only looking at divorced people. So you got to watch for those conditional probabilities. One of the dead giveaways for conditional probabilities is a prepositional phrase for terms like of these people, right? And this one, what's the probability that a randomly chosen divorcee smokes? So this one, I'm choosing randomly from divorcees and this characteristic, right, that they have. And so that becomes the verb in this situation, right? So what is the probability that two randomly chosen people are both married and smoke? Now on these we have to be careful, because on this particular instance we have to think about this. When you went and to choose your randomly chosen people to be both married and smokers, would you choose one and then chuck them back in the pot or not? Well, in actuality, we don't chuck them back in the pot, do we? We say, okay, person number one, come forward. Tell me, are you divorced? Are you a smoker? Sure, okay, great, we've got you. Person number two, come forward. And so that person number one doesn't even have a chance of being chosen again. So this is actually sampling without replacement. And so the probability that two randomly chosen people are both smokers and married, this is equal to the probability that we have a smoker and married, right, times the probability that we have a smoker and married, given that we already had a smoker and married in the first place, right? And I'll use it that way, just little subscripts there. That's kind of hokey, but you know what I mean, hopefully. And I'm going to put this in black because I'm out of paper. So I'm going to go over here and I'm going to say, okay, so the probability that the first person is a smoker and married, so smoker and married, there are 54 of those, right? Out of all of those, because those have both characteristics, right? So I was choosing from all the people, 54 out of the 350. And then times, now the next go around, right, if I want to choose another smoker that's married, I only have 349 people in my bag to choose from, and only 53 of them are smokers and married. So that's what my probability is going to look like, and that's where the conditional probability comes into this one. So this is a little bit more complicated, right, to figure out what my probability is, but I could certainly multiply that out and find it out. But of course, I'm going to go ahead and not calculate it. Now, I'm out of paper, and I'm going to stop my video after this and then come back and let you guys have done these problems on your own, and then you'll be able to check and see how you did. So you're going to take the car dealership example that we had before, and I want you to answer these 3 questions. You're going to find the probability that a randomly chosen business is good or has been in service less than 10 years, so you're going to practice your compound events again. Find the probability that a randomly chosen business has been in business 10 years or more is bad. So that a randomly chosen business that has been in 10 years or more is bad. Think about that one. Be careful. And then find the probability that 2 randomly chosen businesses both have good service. And again, think about how you'd really do that in real life. Don't just think, oh, I'm going to choose a good service and then chuck it back in the bag and then choose another good service, right? How would you really do it? You choose one, and then after you know that one, you're going to choose again. All right, so I'm going to let you do those problems. Come back and watch the next video to find out if your answers are correct.